Hi, cool coders. Today we're going to be looking at how to use packaging inside of Python. Now, packaging is a way to install extensions to the Python programming language that will give you some additional functionality that you don't get out of the box whenever you install it. So today we're going to be looking at how to do this in Tony, but there's a lot of ways that you can do this with Python. But the fundamental concept is going to apply to more than just Python. So it's one of those things that you'll encounter a lot as you grow in your coding experience. You'll be wanting to learn how to use a package manager for whatever programming language it might be that you're working with at that time. So let's go right into the deck and then talk about what is a package manager and how to use it inside of Tony through a demonstration. So what is a package anyway? A package is basically an extension to the core functionality of a programming language that's maintained by a third party. So when we installed Tony on our computer for the first time, it installed the IDE and it also installed the core functionality that was built into Python. And that was it. It didn't really go beyond that scope. If I wanted to extend that functionality, I can do that by either writing my own code or I can use code that some other developer wrote. And typically, if it's a developer that wrote the code and they want other people to use it, they will take their code and they will package it up as a single file. So it's usually a bunch of files, they bundle it together, and then they install that into a single package that they take and then upload to a central server, then add it to an index. And that central server maintains the current version as well as past versions of a particular package. Now, one of the things that is associated with packages is other packages. So typically when I create a package, I have a dependency chain of other packages that my package depends on so it can work. And sometimes those dependencies can be very specific versions of a package that I need for my package to work. And this dependency chain is something that can be very difficult to resolve manually. So if I was writing code and I wanted to use somebody else's code, I download it, I install it, then I get some kind of error. This package or this library depends on another library. So I have to go out and find that one. I have to find out what that package is and what the right version of that package is as well. And that kind of manual resolution of dependencies has created the need for the next idea, which is a package manager. Now, historically, as I mentioned, doing all that package resolution, that dependency resolution manually is very difficult and very time consuming and can be very frustrating for developers. And that's what we used to have to do before the idea of a package manager kind of arose. And so to kind of solve that problem of dependency chains and maintaining versions and all that, the idea of a package manager was born in order to do that. And basically all a package manager is a client to that centralized server. It has the ability to go out to that centralized server and download an index of available packages. And then it also has associated with it a dependency chain for every package that is a part of that index. So if I download my package, it's going to have some kind of metadata associated with it that tells me everything I need to know about that package and all the dependencies and the versions of those dependencies. And so whenever I go to install the package I'm interested in, what it's going to do is go out and download all the dependencies that my package needs as well and install those, so I don't have to do all that work manually. And it's also going to get the right versions for it. In Python, the package manager is called PyPy or Pippy, depending on who you ask. I typically call it Pippy, but other folks you might hear might call it PyPy. And the command line utility is called pip. So if you were doing all this on the command line at a console, you would type in pip and you would install packages. But there are wrappers around that, and Tony provides one that is basically a UI for the pip client that will enable you to install packages right inside of your IDE. And for the most part, most IDEs have integrated package management systems right in the IDE, but you can also use the more manual approach, which is using a shell or a console to do that as well. But for our demonstration today, I'm going to use the IDE to install some packages, and then I'm going to run those packages. So I'm going to show you how you can use those in code. And for Python, as we've seen before, once you have that package installed, you can use import to access the package that is installed on your system. So we've used import for other packages that were included with the core functionality, but if I add to that with Pippy, I can then use import to access the libraries and the code that I installed through that package manager. So the two of these work together to fully round out what I'm going to be doing inside of my code. So let's go over to Tony and take a look at how you can install packages through Tony, and then let's use a few of them. I have Tony pulled up right here, and currently I don't have anything up and running, so I'm opening up a file that I've already coded up. It's called plot.py. So if I run this, it's going to crash on me, and notice what it says here. It says no module named NumPy defined. And that's because I haven't installed this package yet. In fact, I haven't installed the packages for NumPy or the one for PyLab, which I've imported here. So these are common libraries that are not part of the core functionality for Python, but they are used quite a bit inside of data science. So folks that do a lot of work with data and AI and things like that will be using these libraries, and these are very common libraries that you'll see for various things. But our focus isn't on these libraries today as much as it is on how to install packages. So to install a package, I'm going to go up here to Tools, and I'm going to go to Manage Packages. Now to install a package, I just simply type in the name of that package. So I'm going to go NumPy right here, and it's going to say find, and it's going to say latest version, stable version right here. It's going to give me some information about this. It's going to tell me who the author is. It's going to give me a summary of it. NumPy is a fundamental package for array computing inside of Python. It also has a number of other extensions to it that are useful for working with scientific data, as well as plots and lots of different kinds of big data analytics tools. I'm not going to get into all that today, but I'm just going to click install right here. And this is going to go out and get the package NumPy right here. You can see that the output is like this. And once it's installed, that's what it's going to show. It's if I click uninstall, it would uninstall NumPy right there. And so NumPy is now installed. So if I close this and run this again, I should get a new error. And the error I get right here is PyLab is not available. And so I can't import PyLab because it is not there. I need to install a package called matplotlib. So I'm going to go up here and go to Manage Packages again and install another one called matplotlib. And it is the one that contains this library called PyLab. So I'm going to import this one, install this one as well. And notice it's downloading this, and it's going to download any other package dependencies that it has. And if you saw that output, it kind of popped up real fast. It showed that there were some dependencies that were already met because I've installed this package already in a past example that I was working on. So this one installs a package called Pillow. It's got some other packages that it installs as well. The bottom line, though, is that installed the things I needed to do the PyLab right here that is going to be used in part right here for these two commands that I'm going to be running. So NumPy, I installed that package, and then I installed matplotlib, which is used for plotting, graphics on the screen. So that is how I install two packages on Python. Now we're going to be looking at this for the next 2 weeks as well. We're going to be working with other packages that are very common in Python, but I thought I would work with these two basic ones today because I can write 4 lines of code to give you a fairly cool demo about what this is going to look like. So let's go ahead and close this and let's run it and see what happens now. And if you run it with all of the packages installed, you get a nice looking plot like this. So basically what this is doing, just to kind of show you what the code is doing, is this is setting up a frame for me, what they call a linear space, and this is going to tell me what is the first number, this is the last number, and this is the resolution, like how many divisions do I want between 0 and 20, how many iterations do I want to have inside of my linear space here. So basically I'm telling NumPy to say, create me 1,000 iterations over a span between 0 and 20. So if you can think of taking a number line between 0 and 20 and divide that up 1,000 times, that's going to give me a linear space right here. And that's what that's doing. And this right here is just creating a formula. And so this is saying, for x, give me a linear space, so 0 to 20 divided 1,000 times. This is saying, give me a formula. This is saying, take the sine of x. And then you can then take this right here and run this plot, and that's what gives us this nice looking graph right here. So this PyLab right here is plotting this out onto the screen, and then this right here is just showing it. So you can do a lot of different functionalities. This is just basically a plot of the graph that I can kind of move around and things like that. I didn't write any code to do this. This is all included in the package that I chose. And so it's basically like a graphing calculator or something like that that allows me to create these nice looking plots using the libraries and the packages that I imported. So I wrote none of this code. I just simply used the code that somebody else wrote, but I had to first install the packages in order to make this work. So let's just change this up a little. If I wanted to do cosine, I could do that, and it's going to give me a cosine plot, which is a functionality that's similar to a plot like we saw with x when we did the sine of x. Or I can do this as y1 and say cosine of x, and then I can do a y2 and do the sine of x, and I should be able to put all those on the same plot at the same time, just to show you that I'm doing something like this. And no, that's not it. That's the wrong thing. I pasted over what I was looking for. I'm going to copy that and plot y2, and I should get 2 plots now. And there is our cosine and our sine function, or sine wave function and cosine wave function on a plot with both of them plotted at the same time. So that's something that you can do with something like NumPy or PyLab for plotting. But the bottom line is that I did not write this code. I used someone else's code, and I installed the packages through my package manager. Then after I installed the packages, I simply just wrote some code that took advantage of the work that was done by another developer and incorporated it into my program so that I could do something that looks like this pretty cool looking graph right here. If I wanted to do something different, you can certainly do that. So let's go and look at the challenge. And I basically just want you to kind of repeat the demo here in the challenge, but I just want you to do something a little different. So let's go over and look at the challenge, and we will talk about that when we get to that slide. So I just want to shout out to the folks that submitted challenges for last week. We have Madison B, Samuel G, Jacob G, and Judson S. Thanks for your submissions, and looking forward to next week's submissions. So I just want to shout out to the folks that submitted challenges for last week. We have Madison B, Samuel G, Jacob G, and Judson S. Thanks for your submissions, and looking forward to next week's submissions. So as I mentioned, for this week's challenge, I want you to basically kind of repeat what we did in the demo where we had Tony install a couple of packages for us. I want you to install NumPy and Matplotlib and use those in your code. Now, if you want to get fancy and do something beyond that, that's fine too. I just want you to install the packages, get used to using the package manager for those two packages, and then I want you to use those in code like we saw in the example that I gave. But I want you to create a plot using the similar to what we just did that we saw on the screen where I use sine and cosine. I don't want you to use those. I want you to use something original. Just don't copy what I did. Basically, you can go out to this URL here on the NumPy documentation and get a list of functions that are supported by the math library that is in NumPy, and you can use any one of those. If you want to plot something that's not sine or cosine, you can use tangent or whatever it might be. I don't care. Just use something that's original and then plot that. And you can change the size of the graph, and you can play with the parameters too, just to see how those two packages implement the particular dynamics that they have. And then you can understand how some other developer writes something that you can use in your code as well. And then plot that on the plot like we saw, and then run your code, and it should pop up a little graphic that you can play around with as well. So again, something that's kind of fun and interactive, that's just not looking at a shell or console like we've typically done with these, but this will give you something that's a little bit more beyond the basic shell that we've been doing up to this point. But we didn't have to write any code in order to generate that window or generate that plot. We just took advantage of something else that somebody did. So that's kind of the cool thing about packages, is some of the heavy lifting for your applications can be done by code that somebody else has already done. So again, something that's pretty cool, and we'll be using it over the next few weeks as we look at extended examples on how you can use different kinds of packages for doing different kinds of things with Python. So looking forward to your submissions, and good luck.
If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron, and there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.